Hello class, in this very short lesson, I'm going to show you the difference between this concept of this thing, choosing a line of regression, the y on x regression line and the x on y regression line. Okay, let's read this very quickly. The y on x regression line is given by y equals a plus bx and allows you to estimate the value of y from a given value of x. So in this sense, guys, what you need to understand from this sentence is that I'm sorry. In this case, what we want to do is predict the value of y when our predictor variable is x. That's what we mean by y on x. We want to predict this based on this. This is the predicted, and this is the predictor variable. Okay, and pretty much the same idea when you talk about the x and y regression line. It allows you to estimate the value of x from a given value of y. Okay, so it's basically the same idea, but in this case, the roles are changed. This is now the predicted variable, and this is the predictor variable. So let's see how this works in a problem. Oh, and by the way, you gotta pay attention to this. If there is a perfect correlation between the data, that is, if all the points lie on a straight line, like if you had a very nice piece of data like this between two variables, x and y, then both of these lines are gonna be the same. But in most cases, we know that this is not the case in most examples, and so they're gonna be different. These two lines are gonna be different. So let's see how this works by means of an example. Let's solve one of the problems in the book. Let's solve the first one. This one right here. What we have is this. We have 7 different theaters, and the table below shows the cost of theater tickets. Okay, and we are labeling this variable x. Okay, so this is, for the moment, this is our independent variable. Our input, I mean, we can call this either independent x for the moment is the independent variable, or the input, or the predictor. And let's continue reading. It shows the cost of theater tickets and the number of tickets sold in that theater over the course of a week. So tickets sold, that is labeled as the variable y, and we can interpret this as the dependent variable, dependent, or the output variable, or the predicted. In the meantime, from the start, okay, what is the x? X is the cost. What is y? Is the sold tickets. I'm gonna write s. Okay, remember the TI only understands x and y. It doesn't understand any other variable, really. So just bear that in mind. Okay, so the first task is this: find the regression line of y on x and use it to predict how many tickets to the nearest whole number would be sold at a theater which charged $20 or 20 pesos per ticket. Okay, so how do we do this? We go to the TI, and the first thing we have to do is input all of this data, bivariate data, into a spreadsheet, right? So let's do it. Remember, we go to the spreadsheet. We need to label our columns. And here I'm gonna put the cost, and here the sold tickets. And basically, I'm just gonna input the the table, right? That's all I need to do here. 12, 15, 18, 18, 22, 25, 30. Then we have this 45, 44, 45.2, and 40, 34, 26. Okay, that's it. So this is my data set. Each one of these is my is one of my this is an entry in my data set or a data point, right? This is another one, this is another one, and etc. Okay, so let's do a regression, a linear regression. What does that mean? It means that we will be getting, let me write that for you. Gonna be doing a linear regression. What is this? This is the process by which we find the line of best fit. Okay, and what is the line of best fit? It is a line that can predict for us, for example, how many tickets we're gonna sell depending on the cost of our ticket, right? It helps us predict. In this case, if I consider this my independent variable, the one that goes in here, right, in the horizontal axis, the line of best fit will give me the predicted number of sold tickets. Okay, so that's what I want to do, and that's what linear regression is. It's a method which I repeat, guys, at the moment you don't understand because it's highly technical. I will be showing you in a bonus when I have time for those that want to see it, or you can just look it up online. It's everywhere basically. Okay, so let's do that with the TI. How do we do it? We go to menu, we go to statistics, calculations, and linear regression. It's right here. Lista X, that's going to be our independent variable, which is the cost, and the Y variable is the tickets sold. We click on OK, and here we have um, M and B. What is M and what is B? M is the slope of such line, the line of best fit, and B is the intercept of such line. So let's actually write that down. Let's write in here. Y equals M. Well, I'm gonna round to minus 1.08 x plus this b, which is 61. I'm just rounding, right? Okay, so this is the regression line, guys, for y and x. And remember, what is y for the moment? Y is the sold tickets, and x is the price or the cost. The cost. So this would be the regression line, and this is the one that we call y on x. Either of these, okay? Remember, y is representing s, x is representing the cost. So this is known as the y on x, which is the one that we have been doing at the moment. You may call it this the normal, or the first one we do. Okay, so that's it. This is my regression line. And what is that? How does this help me? Like, what do I want this for? So I can input any cost in here, and I can get the approximate or the predicted value of how many tickets I'm gonna sell. And that is in fact what the book is asking you. later in here. Use it to predict how many tickets to the nearest whole number would be sold at a theater which charged $20 per ticket. So if this is my equation, all I need to do is put 20 here, right? And I'm gonna be getting the predicted number of sales. Let's actually do that. Let's open a new document for arithmetic. Let's go home, arithmetic, and I'm gonna put it here where I want. So I wanna perform this calculation. So the cost is 20 plus 61, and we get 39. 39.4, which is about 39, right? If we round to the nearest what is it? Yeah, to the nearest integer. So we're gonna be selling about 39 tickets for a cost of $20. Okay, that's it. That solves this particular problem. How many tickets are we gonna be selling? Around 29. I'm sorry, around 39. Around 39. Okay, that takes care of the first letter, which is what we have done previously in the most recent video. Now this is the new stuff. Letter B. Find the regression line of x on y and use it to predict the cost of a ticket. You see, now we want to predict the cost to the nearest dollar at a theater which sold 35 tickets. So basically we want to do the reverse process, guys. And you need to understand this. Okay, so this is the y on x regression line. And you may be tempted, you may be thinking that you can actually use it in order to predict not just y on x, but also x on y. For example, algebraically speaking, yes, we can actually give any number here on y, and we can solve for x, right? Like it doesn't have, algebraically speaking, I can either put a value to the x and get the value of y, which is how we use this regression line at the moment. But algebraically speaking, we can also do the reverse process, which is inputting a value on y and getting the respective value of x. Nevertheless, this is not going to work when we are in the context of bivariate data. This is not how that works. You cannot do that. You cannot predict this variable by using uh, by having an input in here using this equation. You cannot do that. Okay, what do we have to do? We have to do the reverse process. Now what I need to do is find the regression line of x and y, trying to predict x when using y as a predictor. And how do we do that? Okay, all you need to do, guys, basically in a nutshell, is now you're gonna consider this variable, the y, as the one on the horizontal axis, as this one, and the cost as the vertical variable. Okay, this is the input variable, output variable, independent variable, dependent variable, predictor variable, predicted variable. Okay, you see, so it's just basically a change of perspective. Now we're going, instead from here to here, we're going from here to here, and that's all you need, guys. That's all you need to understand. How do we apply that on the TI in order to get this thing, the regression line of x on y? Let's see. Where is this? Let's go to the TI. Go to my document. Okay, I'm gonna leave this data in here just for reference. But now look, I'm gonna position myself in here. And now I wanna do this. Remember, we have the data in here, the cost and the tickets sold. And take a look at what we're gonna do next. Menu, statistics. Okay, you're not gonna go here. You're gonna go to the same place, linear regression mx plus b. Okay, click on this. But now, like I said, the only thing you have to make the change for is in the x-axis, which is the horizontal axis. You're gonna put the other variable, which is the tickets sold. This one. You see, previously we had chosen this one, cost. You see, but now we're going for S, tickets sold, and for the Y variable, the cost. We click on OK, and that's it, guys. That's all you need. Okay, and here we have again M, which stands for the slope or the gradient of the line, and B for the intercept. So let's actually write this down, the regression line. And I'm gonna do it in here. Okay, so now this is gonna look like this. Now remember, the roles are interchanged. Now I have the x in here and the y is gonna be in here, and now the slope is this, minus 0.81 y plus the intercept, which is 52. Okay, and if instead of x and y you wanna actually put the variables of interest, which are the cost and the tickets sold, then in here I'm gonna put the cost, and in here the tickets sold, minus 0.81 s plus 52. It's like this. So this is the one, guys. This is the x on y regression line. Okay, this one, which if you notice is different than this, right? Like what I mean is this, guys. You are not going to be obtaining this one out of this. Okay, that's my point. That's what I'm trying to tell you. And you can use this one to predict cost by having the tickets sold, the number of tickets sold. And the book is asking you for making the following prediction. Um, Predict the cost of a ticket if you sold 35 tickets. Okay, so basically I'm gonna put in here 35 tickets sold, and I'm gonna predict the cost. Okay, let's do it. Okay, and we round to the nearest integer because that's what they told us in the book, and this is going to be 24. Okay, so if we sell 35 tickets, basically we can predict that the cost of each of those tickets was 24. And that's how it's done, guys. That's how this is done. It's not the same, the y on x regression line and the x on y regression line, and all you need to do is basically a change of perspective like I showed you here. Okay, so that's it, guys. um, let's do this one on your own and tell me whether you can do it or you have it dropped. Thank you.